My name is Ichitoshi Takehara from Kagawa University in Japan. Today, I'd like to talk about evaluation of processing time in trial and error function of security exercise system for security business. In recent years, cyber attacks have become more increased, so it is necessary to nurture more security personnel from students. Hardening exercises, which are conducted in large companies, are effective in training security personnel. In contrast, general companies and universities have so far educated through only classroom lecture. Nowadays, general companies introduce hardening exercise. Even universities introduce it in trial basis. In the future, hardening exercise will become widely applied. In this presentation, I'd like to talk about a hardening exercise system for university students. Hardening exercises are hands-on exercise, such as incident response. Exercise system assigns variable virtual web service for each theme. Students play the role of CSAT, such as server operators and leader position. Exercise instructor system attacks the server on vulnerability. Students find the attack and work together to defend in real time. I'd like to talk about related work. As general hardening exercise, cyber euro, mini hardening, and micro hardening are exercises that respond to incidents occur on exercise system in cooperation. They are designed for security practical employees. Also, VLAB, Cyrus, and Cyclone are construction support systems that build exercise environment. They need to use high-spec machine for building. Now, I'd like to talk about our proposal exercise. In conventional exercise, students receive continuous attack during exercise. They can only try one of the possible defense methods against an attack. In this figure, red circle mean attack and green square mean defense method. Against attack A, defense A is only tried. During conventional exercise, student continuous defense method against attack. So students can't learn defense method enough. In contrast, in our proposal, students are revealed the state of the exercise. They can try defense methods against the same attack. For instance, a student performs a save operation in advance as save point, and try defense A according to the attack A. When the student wants to try the other defense method, they will save new save point, restart to previous save point, and try defense A prime. So students can learn different kind of defense methods again and again. In order to realize our proposal, we develop a hardening exercise system with the trial and error function. This figure shows an example of web-based screen of trial and error function. In panel A is CUI terminal. Students can access a virtual machine to apply defense methods. In panel B, they save the exercise state as save point. In panel C, they can restart to any save point. By applying multiple methods, save points are created as a tree structure. The quality of the defense methods can be evaluated using defense score as an index. I will show an example of exercise using the trial and error function. Before being attacked, a student saves the exercise state for later iteration. After becoming aware of attack, the student restores save 1 to take precaution against the attack. The student executes defense method 1, checks if the attack is definite, and saves the state as save 2. The student then restores save 1 again, and tries other methods and compares each result. The student can learn that method 2 is best. This figure shows the architecture of our proposal system. It consists of these virtual machines. At Defense VM, an EC site is running with the vulnerability intentionally for educational purpose. Students defend EC site from attack by Attack VM. At Attack VM, it attacks Defense VM based on the scenario. The exercise scenario describes the start time and content of the attack. At Score VM, it monitors the risk of vulnerabilities and errors in EC site, and then calculates defense score from them and records a pair of defense score and the elapsed time. The Defense VM manages on elapsed time of the exercise. When the elapsed time matches start time in scenario, Attack VM attack to Defense VM. When the Defense VM is restored, the elapsed time is also rewind, so that the same attack can be received even after restoration. Only Defense VM needs to be saved and restored. The trial and error function manages the snapshot of the Defense VM as save point. The snapshot is taken by using the snapshot function of the virtual machine. The progress of exercise using defense methods and the timing of using trial and error functions are different among students. It is necessary for each student to manage the defense VM individually. We use parent-child relationship record file and active save point recording file for managing save point of each defense VM. Students can use the trial and error function on their own timing. I'd like to talk about how to manage save point using files. Save points are farmers as a tree architecture. Parent-child relationship record file contains the relationship of parent and child snapshot name. Active save point recording file contains the current save point. Trial and error function is automatically saved as root at the start of the exercise, and active save point recording file is returned root. Parent-child relation record file is empty. When the student saves branch 1A as child of root, the file is return pair of root and branch 1A, and the file is changed to branch 1A. When the student saves branch 1B as child of branch 1A, the file is return pair of branch 1A and branch 1B, and the file is changed to branch 1B. When the student restores root save point, the file is not written, and the file is changed to root. When the student saves branch 2A as child of root, these files are written in the same way as before. I'd like to talk about evaluation experiments. We estimated that how many students can exercise on our developed system. We set a requirement that save restore operation is done within 60 seconds according to this reference. As experiment methods, first, generating recipe, simulate each student exercise. Second, measure time of save and restore operation. Use a recipe on single defense VM. Third, measure on multiple defense VM to estimate how many defense VMs can be executed or save and restore operation within 60 seconds. This experiment simulates a save and restore operation performed by a student. The timing of save and restore operation is written in a recipe file. These figures show some pattern of save and restore operation. The blue circle means save operation, the blue dashed arrow means restore operation, and the orange box a sleep command instead of attack and defense duration. In this pattern, the order is save, restore, restore, and save. The number of operations is from 2 through 5. Sleep duration is randomly generated. These tables show evaluate for experiments. Upper table shows host machine specification, and lower table shows virtual machine specification. This experiment uses a virtual machine with 3 different memory sizes. This slide shows operation time of saving and restore using a single VM. All of restore time was much shorter than 60 seconds, regardless memory size. So restore time meet the requirement. In contrast, save 2 that occur after restore time was longer than save 1 time of all memories. As the allocated memory increased, the save time was increased. Therefore, we hypothesize that saving after restoration takes longer processing time. These figures show operation time of save and restore using 12, 16, and 20 VMs with 512 MB memory. Our hypothesis was correct because all save time after restoration in green circle took a long time. Save time is over 60 seconds in 16, 12, and 32 VMs. I'll talk about 3 discussion points. First, the number of students who can exercise is 12, since 12 VMs meet the requirement on one host machine. In Japanese university class have about 50 students, so class need to prepare for host machines. Second, when saving after restoration, the number of disk I/O was not so increased, so there is enough memory space for cache. So the cause is not memory or disk I/O. We think QCOW2 of virtual disk image format is cause. Third, the save time was varying widely. It makes students frustrated. SD of saving is from 16 to 36 seconds. However, SD of restore time plus the next save time is from 5 seconds to 10 seconds. From the result, we propose a new function that executes save immediately after restoration. From the viewpoint of the students, the restoration takes 60 seconds. They think about the next method during the restoration. In conclusion, Universities focus hardening exercise for security vigilance. However, conventional exercises are for security practical employees. We think it is important that students can learn different kinds of defense methods again and again. So we develop a hardening exercise system with the trial and error function. In this presentation, we talked about implementation of the system and evaluation. In the evaluation, we set the pad limit to 60 seconds of the processing time of operation. From the result of experiment, we found that 12 students can exercise on one host machine. We found that the save operation after restore operation need longer time. Thank you for listening my presentation.